At the very edge of our solar system, there's a region of space where the temperature reaches somewhere between 30,000 and 50,000 Kelvin. That's up to 90,000 degrees Fahrenheit, several times hotter than the surface of the sun. There's an informal name for it, the Wall of Fire, and two spacecraft built in the 1970s, running on technology older than most people watching this video, flew directly through it. Both survived without so much as a scorch mark. And that should sound impossible. But how does anything pass through a region hotter than the sun and come out the other side untouched? How is there a zone of such extreme heat sitting silently at the boundary of everything we call home? The answers involve a bubble that surrounds our entire solar system, a boundary where the sun's influence finally runs out. And what's exactly happening at that boundary is far stranger than what we imagined. Welcome to another episode of SOU Discoveries. To understand what the Voyagers flew through, you first need to understand something most people don't realize. Our entire solar system lives inside a bubble. The sun isn't just sitting there quietly producing light. It is constantly streaming charged particles outward in every direction. Protons and electrons blow off the sun's outer atmosphere at hundreds of kilometers per second. This stream is called the solar wind, and it doesn't stop at Mercury or Earth or even Pluto. It keeps going, past every planet, past the Kuiper Belt, out to roughly 3 times the distance of Pluto before it finally runs out of strength. And as it travels, it carries the sun's magnetic field with it, inflating an enormous protective bubble around the entire solar system. That bubble is called the heliosphere. But the bubble has an edge, because the space between the stars isn't empty either. It's filled with its own thin soup of gas, dust, and charged particles. That's the interstellar medium, drifting through the galaxy, pushed around by the winds of other stars and the shockwaves of ancient supernova explosions. And at some point, far beyond Pluto, the outward push of the sun's wind and the inward press of interstellar space meet. They collide, they shove against each other, and where they do, a boundary forms. Scientists call it the heliopause. It is, in the most literal sense, the edge of the sun's influence. The place where our stars reach ends and the rest of the galaxy begins. And until 2 spacecraft actually went there, nobody knew exactly what crossing it would look like. Voyager 1 and Voyager 2 launched in 1977, 2 weeks apart, on a mission to photograph the outer planets. That mission ended decades ago, but the spacecraft kept flying outward year after year. Voyager 1 got there first. In August 2012, after 35 years of flight, its instruments registered something dramatic. The steady stream of solar particles it had been swimming through its entire life suddenly dropped away. And at the same moment, the count of galactic cosmic rays, particles from outside the solar system, shot upward. The spacecraft had crossed the heliopause. It was officially in interstellar space. It became the first object built by human hands to ever leave the bubble. Voyager 2 made its own crossing 6 years later, in November 2018, at a different location along the boundary. And its crossing mattered enormously, because Voyager 2 had something its twin didn't, a working plasma instrument. Voyager 1's had failed back in 1980, which meant it could only measure the boundary indirectly. Voyager 2 could take the temperature of the plasma directly as it passed through it. And what it measured at the boundary is the number that launched 1,000 headlines. The plasma at the heliopause was somewhere between 30,000 and 50,000 Kelvin, hotter than anyone had predicted, several times hotter than the surface of the sun itself. Here's the question that should be bothering you right now. If that region of space is up to 8 times hotter than the surface of the sun, how did 2 spacecraft from the 1970s fly through it and survive? The answer comes down to a distinction most of us were never taught: the difference between temperature and heat. They sound like the same thing. They are not. I'll show you exactly what that means in a second. But first, Voyager carries a golden record into space, recorded in 55 human languages. Most of us can barely manage a second one, and that's on my mind, because in a few weeks, I'm flying to Spain for the total solar eclipse. And what I'm most nervous about is freezing up at a cafe, pointing at a menu like a clueless tourist. So this time, I did something about it, and that's thanks to today's sponsor, Babbel. Babbel is one of the top language learning apps in the world, and the reason I actually stuck with it is simple. It doesn't waste your time. Every lesson is built around things you'll really say on a trip. And here's what sold me. It's designed to get you having real conversations, and in about 3 weeks, you can start speaking a new language. So I'm not sitting there memorizing random words. I'm going to walk off that plane in Spain and actually be able to talk to people. I'm on desktop here so you can see it, but it's just as easy on your phone. Here's what I've already got down. Gracias. Thank you. La cuenta, por favor. The check, please. ¿Cuánto cuesta? How much is it? And my favorite, el cielo, the sky. So if you've got a trip coming up, or you're just someone who keeps saying you'll learn a language and never actually start, Babbel is giving you up to 55% off your subscription. The link is right at the top of the description. And I'm genuinely curious. Drop a comment and tell us what language you're learning, or want to learn and why. Now back to space. Temperature measures how fast individual particles are moving. Heat is about how much total energy actually gets transferred to you. And the key to the whole mystery is this: the boundary region at the edge of the solar system is one of the emptiest places we have ever measured. The particles there are astonishingly fast, genuinely carrying the energy of a 50,000 Kelvin environment. But there are almost none of them. Space out there is so sparse that the particles almost never hit anything. Think about it this way. If you've ever opened a hot oven, you know you can hold your hand in the hot air for a second or two without harm. But if you touch the metal rack at the exact same temperature, you're burned instantly. Same temperature, wildly different heat transfer. The air has few particles touching your skin. The metal has trillions. Now take that idea to its absolute extreme. The heliopause is like an oven with almost no air in it at all. Each individual particle out there is blisteringly energetic, but they are so few and far between that the total energy actually delivered to a passing spacecraft is close to nothing. The Voyagers flew through a region with a temperature higher than the sun's surface and barely felt warm. So if it's not a literal wall of fire, why do scientists care so much about it? It's because that boundary and those temperature readings answered questions we've been asking for half a century, and raised a few new ones we still can't explain. First, the heat itself was a surprise. The plasma at the boundary was hotter than the leading models predicted. That tells us the collision between the solar wind and the interstellar medium is more violent and more energetic than we understood. The particles there are being accelerated and compressed in ways our theories hadn't fully captured. Decades-old textbook diagrams of the solar system's edge had to be revised because 2 old spacecraft took an actual measurement. Second, and this one genuinely puzzled scientists, both Voyagers found that the magnetic field outside the bubble was aligned with the field inside it. That wasn't supposed to happen. The sun's magnetic field and the galaxy's magnetic field have no reason to point in the same direction at the crossing point. Either it's a strange coincidence, or there's something about how the boundary works that we don't yet understand. And third, the 2 crossings happened at different distances from the sun. The bubble, it turns out, isn't a neat sphere. It breathes. It expands and contracts with the sun's 11-year activity cycle. And it's likely squashed and stretched by the interstellar wind hitting it from one side, possibly shaped less like a ball and more like a comet, with a long tail streaming behind the solar system as we orbit the center of the galaxy. 2 data points collected 6 years apart from the only 2 spacecraft ever to make the journey. That's everything we have, and every one of those data points rewrote something. There's one last thing worth knowing. Crossing the so-called wall of fire doesn't actually mean leaving the solar system. The sun's gravity extends far, far beyond the heliopause, out to the Oort cloud, that vast shell of icy bodies that marks the true gravitational edge of the sun's domain. By that definition, Voyager 1, despite 49 years of flight, despite being the most distant human-made object in existence, has barely stepped off the front porch. It will take it roughly 300 more years just to reach the inner edge of the Oort cloud, and tens of thousands of years to pass through it. But here's what it has done. This year, Voyager 1 crosses a threshold no machine has ever reached. 1 full light day from Earth, a distance so vast that its radio signals, traveling at the fastest speed the universe allows, now take an entire day to reach us. It is running on its last reserves of power. Its instruments are being shut down one by one to keep it alive, and the data it sent home from that boundary crossing in 2012 remains some of the most precious information in the history of space science, because no other spacecraft is anywhere close to repeating the journey. So thanks for watching, and thanks to Babbel for sponsoring this video. If you've got a trip coming up, or just want to finally learn that new language, it's up to 55% off with my link in the description. Make sure to check it out.